Okay, everyone, I'm going to quickly go through what we talked about in class so far with area between two curves and how it's actually really a review of stuff that you already know, that something like this curve that you see here, y equals 4x minus x squared, if you wanted to find the area, you would actually just integrate that from this x value to this x value, from 0 to 4. And you would know how to integrate that using your x to the n plus 1 over n plus 1 for integrals. Then we discussed, okay, how does that change if now instead of just being bounded by the x-axis, if you are instead bound by a different curve. So we looked at, all right, if the top curve is 4x minus x squared, if you were to integrate that, and we looked at, where you would want to integrate it to this place right here, that would be finding you this area. And if you integrated the x squared curve to that same point, from the same point, that would give you this, and what you want is that little in-between part, so you were able to determine that to get this area only, you have to take the area under the top minus the area under the bottom. And instead of making two separate integrals, you could put them together. Okay, A and B in that last graph would have been the points of intersection of the two graphs. And again, in class we figured out algebraically how to find this. So this would be your top curve, and g of x would be your bottom curve. Pause and read this slide and write it down if you need to. And again, sometimes the curves are written, if it's something like this, then that's a sideways parabola, which would be some type of x equals negative y squared graph. You could also have a line. In a case like this one, you would go right minus left. Right minus left. And then just make sure that you realize your bounds would be y bounds. So instead of going from, A to B with x values from your x-axis, you would be going from, we're going to call those C to D, and those just represent y values. Okay, so let's start with a problem like this. I was thinking about doing a picture-in-picture with the calculator, but I know that at this point you know how to integrate with your calculator. I'm guessing, looking at these functions, especially looking at this one, that we might have a natural log in our answer anyway. So this wouldn't be a calculator problem. But I don't want to jump too far ahead. Let's see what we're going to do here. Looks to me like this is and do you see it? You want to see if you're doing a right minus a left or a top minus a bottom. So there's one function. Here's the other function. So, and we have y equals a function of x, y equals a function of x. So it's looking like we should definitely be doing a top minus bottom. Area equals, see if you want to pause this and set up the integral yourself. And yes, anybody who noticed, I wrote over that. I thought it was a 3, but it was a 2. I just checked back at the book there. Now, where are we integrating from and to? Well, it's obviously from the y-axis, so this is x equals 0, and you're going to the line x equals 2. We have our top minus our bottom, and you're kind of going to look at two separate ways to integrate this. You could do it on your calculator, but hopefully you can tell that this part is going to give you a natural log. And since you're going to have a natural log, where we want to pay attention to what our u is going to equal, so that we are conscious of, the fact that we may or may not have a coefficient, but this is just du equals 1 dx. So we don't have to worry about kicking out a 1/3 or anything. Now over here, let me try a different color. Your u is going to equal x plus 2. And again, now du is just dx, so we don't have to worry about a coefficient there. Hopefully now when you integrate this, you're to the point where maybe you can go, okay, u to the 1/2 over 1/2, but I'm actually going to say, I'm going to put my u back in, and again, I'm integrating u to, integrating u to the 1/2 gives me u to the 3/2 over 3/2, minus, this was a different u, this one was just 1 over u, so now we have the natural log of the absolute value of u. And the reason why I didn't leave everything in terms of u's was because they're different u's, right? So if I leave everything in terms of u, I would have to have two separate integrals with two different sets of bounds. Now I could just put the 0 and the 2 back in because I left it in terms of x. And now I'm going to have 2/3 times, if I put a 2 in here, and so here I get 4. The square root of 4 is 2, cubed is 8, minus the natural log. Now I'm going to plug in the 2 and get a 3. Absolute value of 3 is 3. And now I'm going to plug in a 0. That gives me 2/3. When I plug in a 0, I get 2 square root of 2. Square root of 2 cubed is 2 times the square root of 2, minus the natural log of 1. And I'm a little bit out of room here, so I'm going to, since I didn't leave an extra page in here, just kind of go sideways. Sorry. So what do we have? 16/3 minus the natural log of 3 plus 4 times the square root of 2 over 3, and the natural log of 1 is 0. So I can leave it like this. I guess I could probably, if I had more room, and you guys might want to do this, I would put this term together with this term and make that 16 minus 4 times the square root of 2 all over 3, and then minus the natural log of 3. For right now, I'm going to end this lesson there. What you should do now is try this problem. Let me make it a little bit bigger. Try this problem on your own. X equals y squared minus 4y. Let me try to use the same colors as they have. Is this function, because a positive y squared opens to the right. So that's x equals y squared minus 4y. And then we have x equals 2y minus y squared. So think about how you would want to set up this integral. The only start I'm going to give you is a equals, and I'm leaving the rest up to you until the next video. So try it. I might throw in some quiz questions about this. And again, I'll pick this up in the next video.